Hey there, students. Here's a video to show how to do a problem from Chapter 11, Section 2 involving contingency tables and variable independence. So this is problem 18 from homework number 14. And so it states that the results from a civil servant exam are shown in the table to the right, which is this table here. And it asks, is there sufficient evidence to support the claim that the results from the test are discriminatory? And says we should use a 5% significance level. So what does that mean? Well, basically, this is a test on whether your chance to pass or fail this exam was somehow dependent on whether you were white or a minority. If there was a dependence between those two, meaning that whether you're white or a minority changes your chance of whether you pass or not, then that's discriminatory. But if your chance of passing or failing has nothing to do with whether you're white or a minority, if those are independent from each other, then that's not discriminatory. It's just whether you passed or not. So when we are setting up a hypothesis test to see if these results were dependent, it is always the null hypothesis that they are independent from each other, meaning that one, they have the same pass rate, depending on, not independent of whether you're white or a minority. And the alternate hypothesis will be that there's dependency, that they're somehow dependent on each other. So looking at the choices here on part A, it says white and minority candidates have the same chance of passing the test. So that would mean that they are independent of each other. White and minority candidates do not have the same chance of passing the test. That would mean that they're dependent on each other. So that's what we want. We could read the rest, but that's the configuration that we want. So the null hypothesis is that they're independent, and the alternate to that is that they don't have the same chance of passing, that there's a dependency there. Okay. So now the problem wants us to come up with a test statistic, and notice it has the chi-squared label there. So this is a chi-squared distribution on a contingency table, checking to see whether the variables are dependent or independent. So I'm going to click on the box to the right of the table so we can open it in StatCrunch. And let me maneuver this a little bit. So now we have our small little contingency table opened up in StatCrunch. And so I go to Stat, and I go to Tables, Contingency, because this is a contingency table. And they summarized the results here. They didn't list each of the candidates separately. They summed them up for us. So we're going to go to With Summary. So again, this is a contingency table. So I went under Tables, Contingency, With Summary for my choice. So then StatCrunch wants us to select which of the columns had the results in them. So for example, the first column has the labels for white candidates or minority candidates. So we want to instead pick the column that has the passed, and I'm going to hold shift so I can collect them both, and the failed. So those are the columns with the observed results in them. The row labels is the column with the little just underlined score here. That's where the labels are for the rows. So then if I go down here a little bit, we can pick different things to display, but we'll just leave that as a default. What we want for a hypothesis test is the chi-squared test for independence, because we're testing to see if the variables are independent or not. And this is a chi-squared test. And so that's it. So what did I click in here? I selected the rows that have the columns that have the data in them, and then the labels were in the column under the underscore, and then I selected chi-squared test for independence, and I hit compute. So here's our results in this little box here. So they show us the little table here, and they show us the totals, both of the how many white and minority candidates are totaled here, how many passed and how many failed here, and the total for both in the corner. But what we want is the chi-square value, which is here, and they want us to round this to 3 decimals. So I'm going to go grab this chi-squared value, and the third decimal place is a 5 that does not need to be rounded up. So I'm going to click on that and stick that in here. See, it looks like that's right. Double checking. So it's happy with that. So then they want the p-value. So I'm going to look over at the p-value here, and they want that to 4 decimals, which is what's given. So I'll just grab all of those, put that in over here. That looks right. Double checking before I check my answer. Okay. And so then finally they want a summary statement. And again, in general, the thing to remember for all of these hypothesis tests is if the p is low, the null must go. And the low point that we have to get underneath is the significance level of 0.05 or 5%. And this is like 27%. So in this case, the p is not low. That means we cannot reject the null. And we have to choose that one. There is not sufficient, I'm looking at A, there is not sufficient evidence to reject the claim that the one is more likely than the other. No, that was not the claim. The null claim is that they're independent. They have the same chance, and we are not rejecting that. So there is sufficient evidence. No, there wasn't. The p was not low. There is not sufficient evidence to support the claim that the results are discriminatory. That's the one we want. In this case, it's the fourth one, D. And that's it for this problem. Okay, so just to summarize, this was a problem from 11.2 with using a contingency table and checking for independence of the variables. So we performed a chi-squared test in StatCrunch by going to stat tables contingency with a summary, and then we did a chi-squared independence test to come up with the test statistic and the p-value to perform the test. I hope that helps. Keep up the hard work. We're near the end.